Example 13, unlucky 13, or lucky 13, depending on your perspective. So here we are trying to derive pi, which is just a number, over the fraction, or rather over the quantity, square root of x minus 1, all raised to the 1/3 power. So we have all of our x stuff in the denominator, just like in the last example. We also have this number pi in the numerator. That's not going to confuse us at all. We're just going to pretend that it's just a number, okay? So what makes this challenging is that we have this exponent in the denominator. We're going to have to move everything up to the numerator just as we did before. We also have this square root of x that we're going to have to turn into a power on the inside part of this function as well. All right, so this is going to require a little bit of algebraic manipulation in order to derive this using the chain rule. Okay, so let's first bring everything up to the numerator where it belongs. So we have d dx pi times square root of x minus 1 to the minus 1/3. Okay, now it apparently looks like we can use the power rule on the outside function. The outside function in this case is going to be pi parentheses to the minus 1/3. Now the inside function is the thing on the inside of the parentheses, as usual. However, in order to derive this, we need to convert this to a power. We need to convert that square root to a 1/2 power. So we'll do that kind of all in one fell swoop here, because the only way we're deriving that is if we know it's a power. All right? So derive the outside. This gives us pi over minus 1/3, or minus pi over 3. Same thing. All I did was take the exponent, and I brought it down in front and multiplied it to the pi. That's all I did. Okay? We put the parentheses right there. Subtract 1 from the exponent, which gives us minus 4/3. Okay? Because you're subtracting 1 from a negative, something that's already negative. So you had a minus 1/3, take away another 1. How many thirds does that give you? Minus 4 of them. Okay? Then you copy paste the original inside. You can leave that as is. You can convert it there. Don't have to, because you're just copy pasting. Doesn't matter what it looks like. Now you derive the inside function. So it'd be good to look at this version of it, because it's easier to derive, easier to think about. So this gives you 1/2 x to the minus 1/2, and then the minus 1 derives away, so it vanishes. So we have a lot of stuff here with negative exponents. At this point, the derivative is done, but the algebraic simplification is what we need to worry about now. So notice that we have this minus pi over 3 and this 1/2. Those are our constants that are all being multiplied. So what we're going to do is multiply them. How do you multiply fractions? Straight across the top and straight across the bottom. So what does this give you? This gives you minus pi over 6 when you multiply the things that I circled. Okay, and then that's just that step. So let me just copy paste everything else that we got going on here, and we'll handle the negative exponents in the next step. All right, so there we go. Now notice we have a lot of negative exponents that we need to worry about. So we have this square root of x minus 1 to the minus 4/3. That's going to get moved to the denominator. We have this x to the minus 1/2. That also is going to get moved to the denominator. So writing this as such, we have minus pi over 6, because that gets carried along. Then you have times 1 over square root of x minus 1 to the 4/3 times 1 over square root of x to the positive 1/2. All right? Now we just have a bunch of fractions being multiplied. You can multiply straight across the top and straight across the bottom. So this gives you a final answer of minus pi over 6 times square root of x minus 1, all raised to the 4/3 power, times x to the 1/2 power. All of that is in the denominator. Okay? Nothing special happens with this pi. It's just a number. We don't have to do anything to it. Just pretend it's 3.14159265535, goes on forever. You handle it exactly like you would any other number. All right? So with that, that is done. That was example 13. A little bit more algebra, but that's kind of the nature of the beast when it comes to calculus. The derivative part was pretty easy once you rearrange things, but then the algebraic simplification is always the nightmare. All right? So that's example 13.